This is Himabindu from the Department of CSIT. So today in this video I would like to explain about the topic called regular expressions and what are the problems involved in the regular expressions, how we will convert the regular expressions to the regular grammar and the regular languages. So here is the topic which we are discussing about the regular expressions. So we will move into the regular expressions definition. So here regular expressions which are a declarative way. So while defining the regular expression, we can say that it is a declarative way to express the strings we want to accept. So this regular expressions, regular language, these are all comes under the finite automata. So in Chomsky hierarchy, first one is about the finite automata, and the second one is about the PDA, push down automata, and third one is about the context sensitive, that is nothing but linearly bound automata, and next one is about the Turing machine. So now these regular expressions are which are related with the regular languages. So we are in this hierarchy, so finite automata. So basically these regular expressions or regular languages which are going to be used for the construction of finite automata. So this finite automata, which is a simple model which we can give the input to the finite state machine, and this machine will accept this input string, either it is accepted or rejected, So this is the basic model of finite automata. So basically we are giving the input to the finite state machine and we will get the result as an accepted or rejected. That string belongs to the language which is accepted or rejected by the finite automata. So why we are discussing this finite state machine, in a sense, this input what we are giving as a input to the machine, that input which is related with the language called regular language. So what we are giving as an input here, we are giving the input of regular language. So in the regular language, what are the strings we have, what are the words we have, those are given as an input to the finite state machine. So basically this regular expression, so how we will form this regular expression, in the sense, this is about the regular languages which we are converting into a regular expression. So what is the definition, in the sense, it is a declarative way to express the strings we want to accept. So what is this means? It is a declarative way. We are writing the string in a standard format. So that is named as a regular expression. So any terminal symbol belongs to the sigma. So sigma, which is having the values called alphabets, include empty. So which is also including empty. Empty is nothing but epsilon symbol, and null, so which is a pi, or regular expression. So both this sigma and the epsilon and this pi, these are all so regular expressions. Single values are also regular expressions. So that is, I am writing as a regular expression is equal to, it is a sigma. So sigma and regular expression, it is equal to null value, that is nothing but epsilon. Empty is nothing, this is empty. So empty, and regular expression null. So null is equal to pi value. So these three values are also equal to the regular expression. So we can say that either it is a combination of input symbols, or a single epsilon or single null value is also a regular expression. And the operations called union, concatenation, iterations. So they are closure. So iterations are closure, both are seen. Of two regular expression is also a regular expression. Suppose here the concatenation. So suppose I am having the regular expression 1 and the regular expression 2 we have. So we can perform the operations called union and concatenation and iteration or closure. So suppose here the regular expression 1 union regular expression 2 is also a regular expression. That what we are saying. So the two regular expressions with the operation called union, and regular expression one concatenation. So concatenation nothing but it is a dot representation. So regular expression 2 is equal to regular expression. And also another operation, regular expression of 1 iterations. So iterations are nothing but like star with a clean closure will take is also a regular expression. So what we are discussing, so regular expressions of operations is also a regular expression. So what are the operations? Union, concatenation, iteration or closure. So of 2 regular expression is also a regular expression. And an expression obtained by all the rules infinite number of also a regular expression. So here infinite number of input symbols is also a regular expression. So these are the points which we are discussing about the regular expression. So it is a regular expression means it is a declarative way to express the input string. And what are the regular expressions here? The sigma and epsilon and null values are also equal to the regular expressions, and the operation between the 2 regular expressions is also a the output which is comes after the operation result is also a regular expression. So these are the points about the regular expressions, and we will discuss about the regular sets. So what is meant by regular sets? So it's any set that represent the value of a regular expression. So here suppose example we will take one regular expression. So here regular example. So regular expression 1 which is equal to 0, 0 plus 1. So it is a declarative way to represent the string starting with the string starts with 0 and sigma is 0 comma 1. So this is the language which we are written the regular expression. So we will discuss how to build this kind of regular expression in detail. So this is the example of regular expression, and for this we have to get in a regular set. So what is meant by regular set? So a set that any set that represent the value of regular expression. So here what are the sets we have? 0, 0, 0, 0. So either it can start, the string starts with 0, 0 and the string starts with 0 and ending with 1, and 0 starts with 0 and ending with either 0, 1 and so on. So what are the regular sets here? So these are the regular sets. So we can say that we'll take one more example. So here 0, 0 plus 1, 1. So this is one regular expression. So and what are the regular sets for this regular expression? 0, 0 comma 1, 1. Like that we need to write the set of any input strings which are related with the regular expression. So it's called a regular set. So a special set of words over the input alphabet. So what is this regular set? A special set of words, these are also words. So words that ever input words over the input alphabet. So what are the input alphabets? Now we are taking only 0 comma 1, and if you take a sigma is equal to a comma b, these strings or words which are in the form of a or b, like this. So here we will take one more regular expression EAA plus B2. So these are all about the regular set. So the regular set is nothing but any set that represents the value of the regular expression. So any set that represents the value of the regular expression is called a regular set. So it is a special set of words over the input alphabet. So this is about the regular set, and regular expression is a declarative way to express the input string, and this is about the regular set, and we will discuss the regular expressions to the languages. So here we have the language. So the input here now we have the input as a regular expression, and now we need to convert it to a language, regular language or language. So language we need to convert. So here regular expression is input, and we need to take the input value and we will convert it to a language. How it is, we'll see. So here first example is regular expression is equal to A. So A, only a single value is there here. So that the language, so language which represented in the flower braces. So only one value is there. There is no input symbol. Input symbol is also one here. So here only A is there. So what is the language? We have only A symbol. So the language A is equal to A. So this is the regular expression, and this is the output regular language. And for this kind of regular expression, so what is the language here? So there is a concatenation in between this A and B input symbol. So what are the language we have? So language is nothing but what are the strings we can form with the regular expression. So here A, B is there, A dot B is there. So what is the language? The only string we have only AB. So the language is equal to AB. And here next regular expression is A plus B. So plus indicates either it starts with, we have a two options. Suppose here I will take example Q0 and Q1. So here we are going for, we are taking the inputs to here, and it is having, so Q1 and Q2. So here from the state Q0, while giving A input, it is going to the Q1 state, and B at the same time, we are giving B as an input, it is going to the another state. So this type of this type of transition diagram, we will represent it as a regular expression. So here A plus B. So we have two choices here. So either it can move to the A direction or B direction. So this kind of two choices which is represented with the plus symbol. So here A plus B. So what it indicates, the string either it starts with A comma B. So here only no more iterations are there. So only we have two values. So here either it can start with A comma B. So this is the two values we are having in the regular expression that is represented in the language. And coming to the A plus B. So here one more concatenation operation is there. So what is the language? So language, as we discussed, so we need to write the possibilities. What are the possibilities of the strings we have with the regular expression? So here the string starts with either A or B, already discussed. So if it is, suppose it is starting with A, what next concatenation? A, B. So like this we have written. And next, so comma we need to write, no need to write the plus symbol. So we are separating, we are writing all the possibilities of sets, strings we are writing. And B, whether the string starts with B, if the string starts with B, we need to write the B. So this is the language, no more possibilities. So suppose it is having iterations, we need to write many number of values here. So there is no iteration, so that I am writing just two values here, A plus B dot B is equal to, we have two possibilities. The string either it starts with A or starts with B. And ending must and should end with B only. That is what we have written. So this is about the regular expression 4. And coming to the iteration, so A star, that is nothing but iteration. So in this iteration A star, how we are going to write the language? So language is nothing but we have to elaborate this regular expression, and we need to write all the possibilities of this regular expressions into a string. So here A star to star, and this A plus we already discussed in the previous video. So A star which includes epsilon is included. So epsilon is included. And coming to the A plus, epsilon is excluded. So this is the thing we need to note down. So A star, which indicates the epsilon symbol also, and B A plus, which indicates the epsilon symbol is not excluded. Other than the epsilon symbol, we can write all the symbols. So here only one input string is there, so that I will write it as a, so epsilon is included. Star indicates epsilon is included. So I will start with the epsilon, and so suppose here this value is 1, we will write it as a power 1 is a, and a power 2. So this star indicates the iteration. So a power 2, a power 3, and so on. And we can also write the same. We'll elaborate this language. So sigma a power 1 a, and a power 2 is a, and a power 3 a, and so on. So this is all about the A star. So we are converting this regular expressions to a regular language. So regular language, what are the possibilities of strings we are writing? We need to write in a language format. So and next, so a language is equal to A plus B whole star here. So here the string, this A plus B we already discussed. There is a two options, either it can starts with A or B. So here the string which is having A plus B whole star. So here A plus B whole star, which indicates epsilon symbol first, and we'll start with A. And if it is a power 1 and B power B, we are not taking B as an initial state, B as a starting symbol, so that I am just writing A and A power 1, and B instead of this B will write it as a epsilon symbol. And also there is a possibilities of B. So suppose here A is epsilon and B is a B power 1. And what are the combinations we have? So AA and AB and BA and BB. So these are the two length combination. And coming to the three length, so AAA and ABA and ABA, and this is all about BAB and BBA and triple B, and so on. So like this we can write the language. So for this regular expression, so A plus B whole star, the string either it starts with 0 or starts with A or starts with B, and there is a no condition, the substring ending string, so that I can write this language as like here mentioned. So what are the possibilities we have for this regular expression? We will write all the languages here. So this is about the examples, and also we'll discuss A star plus A plus. So here A star we already discussed the language which is so here we are performing the two operations in between the regular expression. So here I can say that it is one regular expression and this is one other regular expression. So with and also we discussed about the union of regular expression is also a regular expression. So here regular expression A star. So this A star so is equal to, so A star represent star is included, epsilon is included, and A plus represent epsilon is excluded. So A star language I am writing A and A triple A and 4 A's and so on. And also I will write the A plus language. So A plus language is nothing but excluding this epsilon. I can write this all the symbols. So A, triple A and 4 A's and so on. So these are the two regular expression and union of these two. And we need to combine these two so that the result is the result. So here I am including epsilon. So A is there, A is there. We can combine this union 2, we will get only A. And all the symbols we are repeating here so that I am writing AA A, triple A, and 4 A's, and so on. So what this language? So it is again A star. So what is the result here? The regular expression. So regular expression. So result, this is also getting the result A star. And what is the language here? The language which is epsilon, comma, AA, comma, triple A, comma, 4 A's and 5 A's, and so on. So this is the regular language what we are all after performing the union of two regular expressions. So this is the language for the regular expression A star union A plus. And also we'll do the regular expression and we'll convert it to a regular language. So for this kind of regular expression, we'll just write, simplify and then write the language here. So here A star, again I am writing the language is equal to epsilon, comma, A, comma, AA, and triple A, and 4 A's, and so on. And also A plus L is equal to, so A plus indicates A, AA, and triple A, and so 4 A's. So coming to the intersection. So union, we just combine the values. So in the first language, what are the values we have, and second language, what are the values we have, and we just combined those two languages and we return one language here. And we need, in intersection operation, we need to separate the common things. So common strings in the both languages. So I will write the language is equal to common. So epsilon is here in this language and epsilon is not there. So there is a no common. So epsilon is not common for the two languages. And A is common, small a is common, and 2 A's are also common, and 3 A's are also common. And so result is A, comma, A, double A, triple A, 4 A's. So and so on. So the language again it is as A plus. Why? Because the A plus which is epsilon is excluded. So that A plus the language and the regular language is also regular expression to the regular language is A plus. Language. So A plus is equal to A, comma, A, triple A, and so on. So this is the conversion after regular expression. The language is like this. And next we have the one more regular expression. So these three regular expressions are all same here. So I will write this regular expression of A plus whole star. So here regular A plus is equal to language A, comma, AA, triple A, and so on. And this plus of whole star. So plus of whole star, which is value, we already have, suppose we'll take A of star. So A of star, which is including epsilon symbol, and A, triple A, and so on. And also we have double A. For double A of star is also E. Star is also having the epsilon symbol, and if you write all these values, I will get the same as A star. So A star value is equal to epsilon, comma, A, comma, double A, triple A, and so on. So this regular expression result is A. So this is the first one, and this is the second and third I will write. So we will see the result of these three regular expression. And this one, second one. So second one is a regular expression of A star. So A star is equal to, so what we have, the epsilon, comma, A, comma, A, and so on. So this is of the star. So we will get, so epsilon star is also having the epsilon symbol, and A star, already we have epsilon symbol, so that I am writing directly. So AA, and so on. So this is A star. So is also A star. So and third one is also the value same. So A star of plus. So A star of plus, which is A star is equal to, so A star is equal to epsilon comma A comma double A and so on. So here plus. So epsilon of plus. So epsilon of plus is also epsilon A, triple A and so on. So the result is A star only. So here the result is also A star. So this regular expression A plus whole star. So A star, A star whole plus is also all having the result as A star only. So the regular expression of iterations is also a regular expression. So that we will we just now discussed about the regular expressions to the languages. So here we will what is the regular expression? So it is a declarative way. So declarative way to represent the string in a standard way. So this is about the regular expressions to the languages. How we are writing the if we are giving as an input as a regular expression and we can convert it to a language, regular language. And now we will convert the given language to a regular expression. So here we have some examples. We will discuss this example so that we will get the clarity about how we will convert the languages into a regular expression. So here we'll start with lower level. So start with A. So the alphabet is A comma B. So sigma is equal to A comma B. So A comma B is there. The string starts with. So this kind of this kind of language, we will write the regular expression is equal to. So the string starts with A. So the string starts with A and the alphabet is 2 we have. So must and should it starts with regular expression A. So that first I will write, before writing the regular expression, I will write the language and then we will write the regular expression. The string starts with A and there is no condition of ending, so that I can write it starts with end with B or end with A, and also the strings end with double A and double B and so on. So these are all the language possibilities of strings we have. And for this for this language, what is the regular expression? So the string must and should it is starting with A. So and the ending is not there is no condition, so that either it can starts with A or B. And also we have iteration here, A, B, like that. So that kind of language we will represent it as a regular expression A. The string starts with A and ending with either A or B and multiple times, that is iteration. So there is a possibility of here epsilon is also. Why? Because only the string A is also there. So why there is no condition of it should be end with. So it is a condition starts with A only. So that I am just writing A after this AB and ending with B or A and double A or double B and so on. So this is the regular expression for the given language starts with A. Like that we will write ABA. The string starts with ABA. The language starts with ABA. So starts with the ABA is the minimum length. So ABA, there is a no ending, so that I will write only ABA first and then I will write either the string ending with A or the string either ends with B and so on. So either it can start end with A or B, so that I am writing the regular expression. So regular expression A, B, A and end with A plus B whole star. So this is the regular expression for this kind of the language. the string starts with A, B, A, and end with AB. So end with AB. I will write the same language first, then we will write it as a regular expression. So end with AB, so that the first initial value is AB, and starting value. So starting value, it again either starts with A or the ending with AB, and B the starting with B also, and there is a condition AA or so starting is combination. So many combinations we have, BB, AB, and so on. And for this kind of regular expression, for this language, what is the regular expression? So the string must and should end with AB, and there is a possibility either it can starts with A or B, and multiple times, so that you can write like this. So this is the regular expression for the given language AB. So ends with the string ends with AB, and the substring ABA is there. So substring ABA is there, so that I will write. So first ABA and the substring. So here the substring, it is not in the starting or ending. So the string ABA, suppose the ending, so substring is ABA and ends with A, and start with A, end with A and starts with A, and starts with B and end with B, end with B, and also we will write, so in between A, so it is starting and ending with A, and B, it is starting with B and ending with B. So these are all the possibilities of the strings which we are having in this language. So and so on. For this kind of language, we will write as a regular expression. So first the substring is ABA. So there is a no condition of starting and ending. So that starting I will write and ending I will write it as a like this. So the string which is having the substring ABA, either it can starts with A or B, or either it ends with A and B. So this is the substring ABA regular expression. So the regular expression for the given language, the substring ABA is A plus B whole star ABA and A plus B whole star. And coming to the language W, the word. So here we are not saying any language, so that so it is input alphabet AB. So that so alphabet, the word length is about 3. So 3 is nothing but like this: triple A or triple B or B A B or B A A and A A B and B triple we already written VBA, so on so on. So these are the possibilities of 3 length strings. So for this regular expression, the language, these are the languages. So I will write it as, so BB and BAB and BAA, comma, and AAB, so ABA and A, B, B, and so on. So what are the possibilities of word 3? We have word, the length of the string is 3. We need to write here in this language. And this language, so simply we will write, so the string either it is starting with either it is A or B. So that I am writing the word as the regular expression as A plus B. So A plus B, and here the length is 3, so that A plus B, A plus B. So why? Because we are not writing iterations here. So regular expression is, so this one for this So regular expression for this W equal to 3. And so here either it is starting with A or B, or middle in between A or B, and ending it is A or B. So minimum here the length is equal to 3 length here. So all we can write, we will simplify these strings and we will get as a result a regular expression like this. And coming to the greater than or equal to 3. So here the language, we already have the length 3 values here. Greater than or equal to 3. So we need to satisfy this condition and also greater than symbol. So greater than this 3 is nothing but 4, 5, 6 and so on we need to satisfy. Suppose here the minimum length is here 3. So equal to 3 is satisfying, and more than that what we will do, we will need to have and one more A plus B, and that is also with the star symbol. So what is the regular expression here? So we will write A plus B. So we are satisfying this equal to 3 condition, so that minimum length is 3 here. So minimum length is satisfied, and then and we have to satisfy this minimum length, and also any increment we need to satisfy. So any increment we need to satisfy, in the sense we need to write it as A plus B star. So here this is must and should, and A plus B whole star. So first condition is equal to 3. So equal to 3 in the sense epsilon we will take, and later equal to 4. So greater than 3 in the sense we will take 4. So that time we will write A plus B and A plus B and A plus B, and now in this part we will take A. So A or B. So A or B. And also we have to satisfy for 5, 6, 7, 8 length. So that time we will take it as A star. So that's why we have written the regular expression. So for the 3 word length, so which is greater than or equal to 3. And now we will write less than or equal to 3. So what is the regular expression? So minimum length, which is 3, is satisfying, and we need to satisfy here. So first minimum 3 we need to satisfy, and so A plus B, and also less than or equal to 3 is there. So in between these two in between these strings we can also accept the 2 length also. So 2 length, how it is possible, in the sense we have to include the epsilon symbol here, and include the epsilon symbol, and here include the epsilon symbol. So here we are satisfying the 3 conditions, so that minimum length is maximum length is 3, and also we can write the language. So minimum length is also satisfied here. So this is all about the regular expression, the word length less than or equal to 3. So these are the regular languages what we are converted into a regular expressions. And also we have some more examples. The string, here we are taking the 0 and 1 as a alphabet. So sigma is equal to 0, 1. And now the strings, all the strings 0 and 1 starts with 0, starting with 0 and ending with 1. So here is the condition. So starts with 0, and we will write the language first. Starts with 0 and end with 1. So in between there is no chance of writing, or every time we need not to write the values here. So minimum length is 0, 1, and next in between this 0 and 1 we will write either it is 0 or 1. So either it is 0 or 1. And also we have the combinations like 0 and 1 in between 0, 0, or 0 and 1 in between 0, 1. And what are the possibilities of 2 length? We will write all the values here. And also 3 length, and in between this one 3 length, and we are writing all the possibilities of 3 length. So these 1 length, 2 length and 3 length, and epsilon is also writing as a regular expression. Either it is starts with, starts with 0 and ends with 1, in between 0 plus 1 whole star. So this is the regular expression. So regular expression what we have converted into a language, which we are converted into a regular expression. And we will take one more example. So here the language will elaborate first. So all strings of zeros and ones with even number of zeros. Even number of zeros. So all the strings zeros and ones. So all the strings with the zeros and ones with even number of zeros. So even number of zeros is nothing but we have 2 every time in the string must and should have the strings 2 zeros. So 2 zeros we need to include in the string. So that I will write the language. So 0 0 the, and also we have 0 1 1. So there is a combination of either it is having the zeros, all the even number of zeros only, so that I am writing here even number of zeros, and we will write the 1 is starting and ending, and we also write the one more 1 1, and the string starts with 1 1, and also we'll write, so there is a iteration of 1, so that I just write it as a regular expression. So 1 star, so first there is a 1 star, and we will write it as a 0 0. So 0 0 0 0, and in between 1 star, and also we will write 1 star, and also we will write the whole star. So the string, all the strings. So here they are saying that the string, even the string which is having the even number of zeros. So that even number of zeros, which is also including the epsilon symbol and 1 star. So here we will write this language. 1 0 0 must and should is there, and next, so 0 1 0 and 0 0 1, and so on we will write. So this is the regular expression what we convert, regular language what we are converted into a regular expression. And next, all the strings of zeros and ones with at least 2 consecutive zeros. 2 consecutive zeros. So that is nothing but 2 zeros at a time we need to write. So there is no space in between. We can't write the 101 like this. So consecutive 2 zeros should be there. So which at least 2 consecutive zeros. At least 2 consecutive zeros. So that at least in the sense we need to write, must and should, we need to write the 2 zeros in that language. So that, so the language, so at least in the sense we need to write must and should 2 zeros, and whether it is starting with 0 and 0 0, and either it can starts with 0 0 1, and also it can end with 0 and end with 1 also. So here this starting and ending we have already discussed the regular grammar. The starting and ending we have 0 plus 1 whole star, and in between this 2 consecutive zeros are there. So we can't write the 0 1 0 here. So that's why, so there is only possibilities of like substring. So 0 0 substring is also same as it is. So the language is substring 0 0, which is having the language 0 plus 1 whole star and 0 0 0 plus 1 whole star. So this is the regular expression for the language to at least 2 consecutive zeros. And we will also discuss all strings of zeros and ones. So all the strings of zeros and ones without 2 consecutive zeros. So 2 consecutive zeros in the sense there is a no continuous 2 zeros should be there. So for that one we are writing the language. So now to all the strings zeros and ones without 2 consecutive zeros, in the sense So 0, 1, 0 we can write, and 0, so 0, the 1, 1, 0, and we also write like this. So that the string, so first one is the string first and must and should it is having the 1 or 0, 1. So 1 or 0, 1. So and also it is a star. So the string starts with either 1 or 0, 1. And also we need to write epsilon plus 0. So epsilon plus 0, so anything, so instead of this symbol we also write the epsilon symbol, and also second one we need to write the 0 must and should, and of b. So this is about the, so B is not there. So here this is about the regular expression for the language without two consecutive zeros. So that these are all the regular expressions what we are converted into a regular languages, and regular language what they are giving as an input, and we can convert that into a regular expression. Here is one language which is having the iterations, so that, so we have the possibilities of here many, we will write the regular expressions based on the values what we are taking as a value n and m values here. So we'll write the first language for the input values, multiple input values are there. So first we will take n is equal to 0 and m is equal to 0. So for this one, so we will write the language is equal to a power 2n. So 2n is nothing but 2 into n is nothing but a power 0, and b power 2 0 plus 1 is equal to b. So only we have b here. So b is b power 1 I can write. And we will take n is equal to 0 and m is equal to 1. So for this one, we will write n is equal to a power 0 and b power 2, m is equal to 1 we are taking, 3 is there. So we will write b is equal to b3. And we will take n is equal to 1 and m is equal to 1. So here a language is equal to, so n value is now 1, so a power 2 and b power 3. So we already written. So a square b cube. So the language is a b b triple b. So that I will write, so a square and b cube. We will write it next later. We will write a square and b cube, and next m is equal to 1, n is equal to 2. So we will take n is equal to 2, and here we will write a power, so n is equal to 1 in the sense a power 2, m is equal to 2 in the sense we will write it as a 5. So here write it as a 5, a power 2 and b power 5 here, and n is equal to 1, n is equal to 2 here, n is equal to 2 and m is equal to 1. So here language, so n is equal to 2, a power 4, b power 3. So here a power 4 and b power 3. So if you observe continuously, we are getting here a power 0 I can write. So here also a power 0. So here if you observe the value of a string, so a value, the power of a is always even number. So a power is even number and b power is odd number. So odd number we are getting. B power is odd number. So for this kind of for these languages, we will write the language. So a power even, we will write it as a, we already discussed in the previous video. So a power even. So even number of a's, we will write it as a EAA star. So this is the we'll elaborate this language so that we'll get clarity. So AA star indicates epsilon, AA, and 4 A's and so on. That is nothing but A square and A power 4 and so on. So even number power is there here. So that we will write the regular expression as a AA star. And for this odd number, we will write regular expression is equal to odd. So B, BB star. So we'll write a language. So B. So initially B is starting and BB is whole star is there. So that epsilon I will write. So first time I will write epsilon and then we will write the AABB and with 5 B's and so on. So this is B power 1, B power 2, B power 3 and B power 5. And we will write this combined together regular expression is equal to A power even in the sense AA star and B power 3 even odd number, so BB star. So these are the two regular expression. So we have the two input values so that we just converted the given language into a regular expression. So these are all about the regular expressions. So here we just discussed about the examples how we are converting the regular languages to regular expression and regular expressions to regular languages. So here we just converted through the examples. So this is about the regular expressions which are having the problems in the languages for the regular languages. These are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.